All right, so just a moment. All right, so I want to welcome you to this lecture. We're going to be looking at common network devices. Just to also emphasize is that keep your microphones muted, more so when you know you have a noisy background, so that we can have a conducive environment. Yesterday, like we have discussed earlier, we looked at the basic network concepts and we tried to go through some of those concepts and try to understand and appreciate how the network has evolved and the different protocols and the different components that make up the network. Now, in this particular module, we are going to look at the network devices, those components, and want to understand what some of those devices do. And it is important for us as security engineers to understand our networks, isn't it? It is important for us to understand our networks because at the end of the day, when we are going to protect our networks, we need to have let me just configure my pen just briefly. It's not writing on the screen. We need to have an understanding of how we are going to be able to allow me to first stop sharing. Mic check, mic check. Can I be heard?
Yes.
We can get you, Mr. Sandy. Go ahead.
Yes, we are getting you.
Okay,
We are getting you.
We are hearing you
thank you.
loud
Thank
and
you,
clear.
I was setting my pen. I forgot to configure it at the beginning of the class, but we are good to go now. We're good to go now. We are good to go. We're good to go now. Okay. Okay. Let me share my screen. All right. So we want to look at the common network devices in this chapter. So let us try and move to the next slide. And we are saying here that moving forward or fast forward, network devices are the basic components of a network. They're the building blocks of our network. And when planning and constructing a network, you need to deploy and configure the network devices to meet network connection or network security requirements. Let me just mute. Okay. To meet our network security requirements. So upon completion of this course, you'll be able to describe Huawei's network devices. You'll be able to describe the functions of network devices. And also you'll be able to log in to network devices and perform basic configuration. But we shall look at this when we get to the labs. I'll be sharing the video how we can download the firewall configuration file, VirtualBox. Lungu, could you please mute your mic? How we can download VirtualBox and how we can install NSP, the one that we looked at later on. So let us move forward. So we're going to look at the basic network devices. I'm going to be a bit fast, so I just beg that you kindly try to move on the same pace with me. Want to look at the router, want to look at the router here. I want to look at some of the architecture and the deployment scenarios. This is a common typical campus or even let's say an enterprise network security deployment scenario. Usually on our network, we have routers, and we said in the previous chapters or previous lecture that basically these are devices for communications across network segments, and we shall look at them in detail later on. But if you want to send packets to traverse different network segments, you need a layer 3 device or you need routers. There are also switches. In our there are switches in our network, and the switch is basically a device for communication on the same network segment. All these guys who are on the same network segment will use switches to be able to communicate to each other. For you to be able to protect yourself from hackers and maybe distributed denial of service attack, you may need to install an anti-DDoS. And basically it is an anti-distributed denial of service system which is deployed at our egress network. It is deployed at our network egress in bypass mode. And it's upstream of the firewall. It's basically to help us reduce the firewall's packet processing and load, because we don't want our firewall to process everything when we can install this kind of system to help us deal with that. Still on our network, we have what we are calling our next generation firewalls. And with our next generation firewalls, we can either deploy them at the network, at the beginning or the entry of a network or the egress to provide preliminary protection or even protection for our data center from attacks. Okay. And then we also have our virtual next generation firewalls, and these next generation firewalls are deployed on our virtual machines here, which we have running, which are in a virtualized environment, and they have similar functions to that of our hardware firewalls. We have our other devices, like these are the access devices, like your VoIP phone, laptops, desktops, and all these are all components or devices that make up a network. You may be having your branch, people out there trying to send you viruses. You have people who are working from home and they're remotely accessing your servers or your systems. So you also need to have things like the NIP, what we're calling the next generation intrusion prevention systems, and these are systems that are developed to detect intrusion and also to prevent the device that can be deployed in the data center to provide protection against intrusion. So basically, you're just protecting us from unauthorized access or intrusion. You can also have, agile controllers on your computer, like in your DMZ, that demilitarized zone. We shall be looking at the firewall zones later on, but basically the agile controller is an automated network resource control system used to access control. It is based on users and applications, and it is deployed in the demilitarized zone. Okay, so I'm going to disable your microphones for now because I am having a challenge muting you and unmuting you all the time. Okay, so let us proceed. I want us to move very fast. So I want to look at a switch, but then I also want to interact with you. I don't want to feel like I'm talking to myself. This is a switch, and I want to give an opportunity to the people who have done networking before to tell us what they understand about a switch. Just kindly put up your hand and then I will unmute you. A switch. Okay, let me go to, I've asked you to unmute, Christopher.
Yes. So, Mr. Sandy, so what I know about the switch, it's a layer 2 device at the data link layer. It it works with MAC addresses. Like it can have a MAC address table that is storing that includes MAC addresses for PCs on a specific network. For example, in this like illustration on the screen, host A, host B, and host C, according to their IP addresses, they are in the same network. So these two are linked. All these three PCs are linked by this switch, and this switch has a MAC address table that has all the MAC addresses for the hosts in the network. Thank you.
All right. Thank you. Thank you so much. Thank you so much. Thank you so much. Thank you so much. So he has said it all. What I want to highlight here is that the switch works at the data link layer and it forwards data frames. It deals with MAC addresses. One thing you should take note, it only forwards packets to hosts within the same network segment, all within the same broadcast domain, all within the same virtual LAN network. Okay, so the switch only works in that aspect. I don't know if I can just Google here briefly for the people who have no idea how a switch how network switches look like. We just Google here and get pictures. For those of you who have no idea, this is how it looks like. It is like a box which has ports, what network engineers call interfaces. These guys here are called interfaces. The holes you're seeing there, or the ports you're seeing there. So this is what we are calling a network switch, right? I hope you can be able to see my screen. This is what you're calling a network switch. It's you put it on your network and you connect cables and you connect different devices onto it. And its role, what it does is to make sure that it forwards packet within the same broadcast domain. So this is an example of a typical switch, and we have here an IP address of this, and it is ending .1/22. It's on a network of one. It's a network of one. It's in a network of one. So all these guys will be able to get packets and receive packets from either host A or host B, because these guys are all within the same broadcast domain. It will need to know the MAC address of the sender and the receiver. To also need to know the source IP address and the destination MAC IP address. So how it works, this is how our switch works. It works there's what we are calling forwarding on switches. When it receives a packet, what is it going to do with it? So like our colleague Ivan told us previously, a switch has a MAC address table, and this table stores the mapping between our addresses and our switch interfaces. So a MAC address table is also sometimes called the CAM table, and the CAM table is what they're calling a content addressable memory. And here we have three modes of forwarding. We have flooding, we have forwarding, and we also have discarding. Here, when the switch receives a packet, it can perform three different types of frame operations, and I have just highlighted them here: flooding, forwarding, and discarding. With a forwarding, or with a, let's just look at flooding. The switch here forwards the frames received on an interface through all other interfaces. Like you hear the word flood, it receives a packet here, it's going to send it to interface 01, 02, 03, 04, and all the interfaces that are on our switch. These are the ports. So what is going to happen when it receives a packet in one mode, it's going to make sure that it's going to forward all the packets. Then there's also what you're calling forwarding, and with forwarding, the switch here, when it receives the frame on an interface through another interface, it does not the switch forwards the frame received on an interface through another interface. So if maybe the packet was meant for this interface. They know that this interface is what is connected to this PC, which has our MAC address we are looking for. But the frame was received through this interface. So what is going to do, this interface will go ahead and forward it to this particular interface to process and go ahead and process the packet. But we are saying here that it does not forward frames through the interface that receives them. This is what when you look at interfaces. So there's also discarding. Discarding here, the switch discards the frames received on an interface. So if it receives it for one reason or another, there's no entry in the MAC table, or it is in unicast mode and it knows, or maybe it's coming from a different VLAN or from a network segment, this interface will go ahead and discard the packet. So the basic principles of a switch are: upon the receipt of a unicast frame. The unicast frame, remember we talked about those frames lastly. We said we have a unicast and multicast and broadcast. We have unicast, we have multicast, and we have broadcast. Unicast is intended to one host, multicast is to many, and broadcast is to all. So we are saying here that if upon receipt of a unicast frame, the switch searches for the MAC address table for the destination MAC address of the frame. And if the MAC address cannot be found, the switch will then flood the frame. And if the MAC address is found, then the switch then floods the frame. If the MAC address is not that of the interface on which the frame was received, otherwise the switch discards the frame. So what is going to happen when it receives a unicast? Unicast means that we already know this packet is going to ABCD. We know his MAC address. We have already embedded his MAC address and is this. We are forwarding it to that. So when it received a packet and it checks through its MAC, its CAM table, it checks through its CAM table and it cannot find that record, that mapping of the port interface with the MAC address, it will go ahead and flood. It will go ahead and send the packet to all the interfaces of the switch. But if the MAC address is found, if it charges through its CAM table and it finds the MAC address, it won't waste time. It will just go ahead and forward the packet to it will go ahead and forward the packet to the intended destination. Or if it is the same interface, then it will go ahead and process the packet. Otherwise, if none of those conditions are met, then it will go ahead and it will discard the packet. So if a switch receives a broadcast frame, this means that it is going to all the hosts on the network. It's going to broadcast and go to all the hosts on the network. So if it receives a broadcast frame, it does not check the MAC address table because it knows already whether I check the MAC address table or not, this particular packet or this particular frame is meant to go to all the hosts in my network. So what do I do this time? I'm going to directly perform the flooding operation. And upon receipt of the broadcast frame, the switch directly floods the frame without checking the CAM table. And for the multicast frame, the multicast, it means you're sending to many hosts. The switch performs the complex processing that is beyond the scope of this course. Maybe for those who are interested in doing datacom or doing routing and switching, you'll be able to dive into those things in detail. So a switch has the capability. Why a switch is good? It has the capability to learn information from the received frame. Once it receives this information from the other PC, to know, oh, this is your MAC address, and this is, you have sent it from this interface. Let me learn it and store it here. So it has the capability to learn information from received frames, and also upon receipt of a frame, a switch checks the source MAC address of the frame, maps this address to the interface that receives the frame, and saves the mapping to the MAC address table. Mojadi, please mute your microphone. Mothobeki, please mute your microphone. Okay, so moving forward, the initial state of switches. So in the initial stage, a switch does not know any MAC address, right? Because they have just connected it and they just put it in your network. You have just connected it, doesn't know any MAC address, and it does not learn any. Therefore, the MAC address table in the initial stage is empty. The initial stage, the MAC address table of the switch is empty. There's nothing there because it has not learned anything. And in, like you see in this example, our switch here, the switch A, it does not have anything at its initial stage. And before receiving a data frame from host A, switch A's MAC address table contains no entry from host A, just like you see here. It has no entry here. Host A is trying to send to, let's say, host B, right? And it doesn't know. So what is it going to do? The first time we said when it doesn't know, those who are attentive, what happens? When it doesn't know the interface which to forward, it's going to do the flooding, isn't it? Yes. It's going to go ahead and do the flooding. So the switch records after it is going to record this interface for one and know that, oh, I received a packet and this guy, host A with this MAC address is connected on interface gigabit Ethernet 0001. This is the interface which is connecting host A with this what MAC address. So it goes ahead and when host A sends this packet, like he was intending, let's say, to send it to host C, it sends an ARP request to obtain the MAC address of host C. Because in the initial stages, it also host A is unaware of the MAC address of host C. We may be knowing that, you know what, host C is our file server, right? And our network engineer told us for us to access our file server, we put in our IP address of 10.1.1.3/24 to access our file server. But for us, we said, remember previously, for us to be able to establish connection, we need to have the source IP address and the source destination, the source MAC address, the destination IP address, and the destination, and the source IP address. So for us to be able, for this guy to be able to send a packet, it needs to first learn and find out who is this guy and what is his MAC address. So it will send an ARP request. We said what is an ARP request? Packet, who remembers?
Address
resolution protocol.
Address resolution protocol. That is going to enable host A to learn about the MAC address of whatever it is trying to send the packet. So it will send the ARP request to obtain the MAC address of the host C, which is sending the packet. So in this ARP request, the destination MAC address is in the broadcast kind of address, and the source MAC address is the MAC address of host A. And after receiving the ARP request, our switch here adds the mapping between the source MAC address and the receiving interface of that MAC address, which is this. It's going to add and it's going to store and do the mapping here in our CAM table, and it's going to save that entry in the CAM table. And after adding the mapping between the source MAC address and receiving interface, the aging time of MAC address entries usually times 7 series, 300 seconds. That's when it will keep on refreshing its MAC address table by default. So please mute. Yes, please. Let us not ask so many questions for us to be able to complete. This material will be shared afterwards and you can ask the questions after, unless when something is really, really burning. So I was saying that the default aging time for most of the Huawei modern switches is 300 seconds by default. And if switch A here receives a data frame from host A again with the aging time, the switch updates the aging time of the mapping host A address and the interface which was able to receive it. So after receiving the data frame from the destination, whose a MAC address is this, also the switch will go ahead and forward the frame through this interface. So when it receives the packet and it knows this guy is on this packet, so it will always be able to send through that interface. So after getting the frame. Remember, initially, because it doesn't know it's a broadcast, so the destination MAC address of that frame is not in the MAC address table, or it is a broadcast address, the MAC address. So what is going to happen? The switch will flood the frames. It will send to host B, and it will also send to host C. And after host C, because it's an ARP packet, the switch is going to broadcast all the packet and are going to go to B and C. But as they're going to B and C, this guy here has taken note of the interfaces which they have used to go through that. Remember, it's a broadcast frame. But B is going to go ahead and discard the packet, right? Because he's going to look at the information and says, no, this is not my IP address. I am not 10.1.3, and therefore I have nothing to do with that information. The packet is not meant for me. I will discard and I will not do anything. But remember, after host C receiving the ARP packet, it sends back the ARP reply. Remember the previous class, we said it sends back the ARP reply saying, hey, you are trying to send something to me. I am the one. This is my IP address and this is my MAC address. Please find it here. So it will send that information back. And once switch C receives this information, it will go ahead also and update its CAM table or its MAC address table and say, oh, so whenever I want to reach host C, I need to reach him through this interface here, which is Gigabit Ethernet 003. This is how I need to communicate and send packets to host C. So therefore, let me go ahead and store and map this guy's interface to his MAC address there. So whenever someone is trying to send packets, I know whenever I receive it from, because remember, switches usually have quite a number of ports. But how is it able to know that, yes, the packet has come in from this cable, which is connected from a computer from somewhere, and this guy is connected to this cable? How is it able to know that it should not send to this interface or it should not send to that interface? By storing the details here, knowing that whenever it's this MAC address, I'm going to be able to send the packet through this interface. And if I send it through this interface, I'll be able to communicate with the MAC address or with host C using that MAC address. Okay, so this is what happens, and we want to look at the router. I'm not going to ask what the router is, but we said it operates at layer 3, and it's a network layer device that forwards packets between different networks. The other one, we're looking at the same networks. This one, we're looking between different networks. I hope that is making sense. So between different networks. So like you can see in this figure, we have our host A here and we have our host B, and they reside on different networks. Host A could be on one network and host B could be on another network. So when host A wants to communicate with host B, host A sends a frame to host B. But upon receipt of this frame here, our router that resides on the same network with host A here, that resides on the same network with host A, analyzes the frame. It's going to get the frame and analyze it. At the data link layer, remember the router analyzes the frame header and determines the frame is set to itself. And it then sends the frame to the network layer. At the network layer, the router determines to which network segment the destination address belongs. And based on the network layer packet header of the frame, it then searches the table and forwards the frame through the corresponding interface to the next hop to the host B destination. So when it gets this packet and it receives it, it's going to look through the details at the data link layer. It's going to see, oh, what is the source IP? It's this guy's IP address, which is in the same network with me. But then also, what is his source destination address? That is it. Where is he trying to send? He's sending to an IP address. And it's not part of our network. It's part of the network of host B. And what is his destination address? For MAC B, the MAC address, but it is not within our network. So therefore, let me get these things. I know that the next hop, for me to be able to communicate to so-and-so, I need to contact messenger B, because he's the one who will also help me forward the packet to where host B is. Host B Router B, will also go ahead, receive the packet, look through it, and say, oh, the next hop. Remember what we did when we are doing the routing, and they are determining the trace route, how they're going to be able a packet to move from one host to another, the route it's going to take, and we are using the time to live value to determine how many hops are in the network. For host A to be able to determine that for me to reach host B, I'll need to go through 1, 2, 3 hops. So these routers and also host A knows already, and router B knows that the next hop to host B, I have to go through this router. So it will send the details until this router will be able to check and see its interfaces, and it will be able to forward the packet. So it will look through all these layers, and it will process majorly basing on the data link layer and also on the network layer. The data link layer, we are looking at the MAC addresses, and here we are looking at the IP addresses. So the router selection, when it's selecting the optimal route, router selects an optimal route for data packets and forwards the packets. So it will go ahead and look at the routers basing on the link speed, basing on the number of hops that are in our selection, and it will be able to select the best route for our packet. We also want to look at another device, which is a firewall, and we are saying here that the word firewall, like you hear the word fire and wall, was first used in the construction field, where a firewall's primary function was to isolate and prevent fire from spreading in the city. Okay, so in the communication field or in the network field, here now the firewall, or the kinds of firewall we are looking at, it is its primarily function is to isolate, it's to make sure that it protects our network. So a firewall is a device that is usually deployed to meet certain requirements by logically isolating networks. It blocks various attacks on the network, and it allows normal communication packets to pass through. And in communications, like I said, or in networking, a firewall is mainly used to protect one network area against network attacks and intrusions from other network areas. That you're going to get your network area, and you're going to protect it against attacks from other network areas. And because of its isolation and defense capabilities, it can be flexibly applied to network borders and subnet divisions, and isolations for you to be able to achieve better protection and isolation. Like you can see in this picture here, we have different areas. We have the production area, the headquarters, and we have our firewalls here to protect us. And we also have here our branch area. We have our data center, and we have firewalls there. We have our registration and distribution, and we have our firewalls that are going to help us protect us from the internet and also from other network areas. So comparing firewalls with switches and routers, the primary function of routers and switches, like we have said, is forwarding, whereas the firewall is controlling. It does not only forward the packet. Once it receives it, it controls and say, you know what, either I'm going to allow this packet or I'm going to discard this packet. According to my control rules, I am not allowed to process this packet. This packet, I am allowed to only send it to this user. Or I'm allowed to process it when it's only coming from this user. So for the switches here and for our routers, their base crop is just basically, for a router, it is addressing and forwarding and ensuring there's network interconnection across different network segments. Whereas here the firewall is going to control packet forwarding. It's going to also act like anti-Trojan horses and viruses. This is what we're calling our firewalls. Whereas a switch is basically for fast forwarding of our packets and within the same network segment. This is what you're calling the switches. So the development or the history or the development of firewalls, it has grown. The earliest firewall can be traced back in 1980s, so it's not a new concept. It has been around for quite some time, and the development has been growing through phases from 1989 all the way to date. We have seen it grow from one phase to the other. So here they were basically focusing on packet filtering, that is access control, what have we got, what, and then they went to application agent, and they're looking at proxy technology, able to control the traffic on behalf of another device and checking the status. Here they were dealing more in session mechanism. From around 1995 to 2004, they are looking at the UTM, the multi-function overlay and dedicated device using technologies like DPI. And from 2005 to 2009, this is where we got what we are calling the next generation firewalls. And they control based on user plus application plus content. We have different zones, security zones, or different firewall security zones, and we want to look at some of them. Security zone, or what we are calling a zone, sometimes we just call them a zone. We have a logical security zone, and we have a network connected to one or more interfaces. So security zones have functions. They are able to help us apply security policies. They help us to apply security policies. Also, the data flows in the same security zone bring no security risk and therefore require no security policies. And also the firewall performs security checks and implements security policies only when the data flows between security zones. So all devices on the network connected to the same interface must reside in the same security zone. So the default zones on a firewall, we have the DMZ, the demilitarized zone. We have the untrust zone, and we have the trust zone, and also we have what we are calling the local zone. The local zone is a zone inside our firewall. The firewall zone is what we are calling the local zone. So we have the local zone, we have the trust zone, the DMZ, and the untrusted zone. Usually the trusted zone has the local zone has the highest number because anyway, it's part of the firewall. The trust zone has the second highest number, the DMZ, and then the untrust zone has the lowest number. So relationships between firewall security zones and interfaces, all devices on the network connected to the same interface must reside in the same security zone. Yep, that we must agree that and the same security zone, and each security zone may contain networks connected to multiple interfaces, and the interfaces can either be physical or they can be logical. So users on the different network segments connected to the same physical interface can be added to different security zones by using logical interfaces such as sub interfaces or the VLAN functions. Yeah. So does the firewall have to have two security zones with the same security level? We want to answer those questions. Does the firewall allow the same physical interface to belong to two different security zones? And can the interface on the firewall belong to the same? Can different interfaces to the firewall belong to the same interfaces? Those are questions of thought. So device login. This one we shall cover more when we come to the labs, when we come to manipulating our firewalls. I think in the next week, Monday, we shall be able to do that. I will give you all the entire weekend to install and configure the applications, and then we shall be able to look at this in detail on Monday. But I just want to go through some of the things and say VRP overview. Someone who was asking me about VRP, we said VRP in full is versatile routing platform, and we said it's the operating system for Huawei's routers, switches, and service gateways to implement network access and interconnection services. It also provides a unified user and management interface. That interface where you put in commands, what, to enable you to be able to, control and implement a control plane functionality where you're able to person configurations and commands and etc. and etc. So it's the operating system, network operating system for Huawei's devices, and the software platform that supports multiple types of devices and also provides TCP or IP, TCP/IP routing services. This is VRP. We have command lines for them, and it is divided into different views. We shall look at these views later on, or I'll just ask you to read and just go through them, because basically they're just showing you we have 5 views where we have I think we have 3 or 4 views. We have user view, system view, interface view, and the protocol view. we shall look at those views, or I'll ask you to read through those views. So to get help, I will not go through these things. I'll ask you to read through them. They're a bit direct forward. But to get help, you just put in the question mark if you don't know the word, and then you'll be able to get the words. So this is just help, and I'm going to skip and peruse through that, and then go to the configuration interfaces. Also, this we shall modify later on when you get to the server. So I'm not going to focus so much on it. And also configuring the routes, I will skip to it and come to here and say we have a device login management. We can log our devices either through the console, either through telnet, or we can use SSH or even the web. These are some of the common ways. If you're going to use SSH, we can use our serial cable or to access it, or even Ethernet cable, and even still the same applies to that. You can put the cable directly into the console port, and then you're able to access and remotely log in into your firewall. So to log in through the console port, I'm not going to go through this. I will just skip this, but let's focus on the web login function overview because we shall use it a lot. And by the default, please take note of this. You can log into the device through Gigabit Ethernet 00. This is the default management interface. Gigabit Ethernet 000 is the default management interface. And you can set the IP address obtaining mode of the network connection to obtain an IP address automatically on the administrator's PC if you want to obtain the IP address automatically. Or you can directly connect the PC Ethernet interface to default management interface on the device, or you can even connect them through a switch. Yes, you can just put it on a switch and then you're able to connect to your firewall. And then to access it, you need to enter this IP address in your browser, and then it will load a page that looks like this. The IP address, I repeat, it is 192.168.0.1. It is a default management IP address that is assigned to our Huawei firewalls. Okay, even the physical firewall, this is the default management IP 192.168.0.1, and the default username is admin in lowercase. The password is admin at 123 with a capital A. I just wanted to highlight that briefly, but we're going to go through these things later on, so do not worry. I'll just skip through them. For now, we shall go through them when we are looking at the labs practically. So I'll just skip through them for now. So the brief overview of device management, still the configuration files. We shall look at them later on and how we are able to start, but we have different types of configuration files, where we have the saved configuration, the current configuration, and we shall be able to distinguish between these two. But the saved configuration file is used for the next startup of our devices, and it is used to store a flash. It is stored in the flash memory or the CF card of the device and persistent across restarts. So when you restart it, then you'll be able to use the saved configuration. The current configuration is a configuration currently in use on our devices, and it is modified by command lines and web operations. It is stored in our memory of our devices, and it persists across restarts. So the common operations for the configuration file, you can save the configuration file, you can erase the configuration file, and you can configure the system software and configuration file for the next startup, and you can also restart devices. Those are some of the things you can do. We shall look at how we can be able to update the firewalls version, and we shall also look at the licenses configurations when we get to that. So quiz number 1, for those who have been attentive, what is the default login IP address used in web login? Just kindly, I think, post in the chat.
Yeah.
Yes, post in the chat.
Mic check.
Yes, please.
The answer is A. It's 192.1681.0.
Okay, yes, very correct. I see most of you got the answer correctly in the chat. I'm seeing Malawi, Akram, Kelvin, Jonathan. Most of you got the answer correct. The answer is A. This is our default management IP address. And what is the default username?
Admin in lowercase.
It is admin. Thank you. And the password?
Mic check.
Admin at 123.
At 123.
Capital A.
Okay, admin at 123 with a capital A. All right, so that brings us to the end of this first slide. And thank you. So let me stop the recording.